Problem 3 in capitalized cost. Calculate the capitalized cost of a project that has an initial cost 1,500 and an additional investment cost of 50,000 after 10 years. The annual operating cost will be 5,000 for the first 4 years, and 8,000 years after. So from year 5, 8,000. In addition, there is expected to be a recurring major rework cost of 15,000 every 13 years, and assume my 15%. How can we solve this problem? And this is capitalized cost, so it means that assume to last forever. When that go to the last slide in today's class, this is step to calculate the capitalized cost. First, draw the cash flow diagram that show all non-recurring and recurring at least 2 cycles of all recurring costs. Find the present value, find the equivalent. So 5-step process, and let's apply that in these problems. So first step is always the diagram. Let's show the cash flow diagram. So first step number 1, we have cash flow diagram. Cash flow diagram. For at least 2 cycles, as you can see, this one is 50,000 after 10 years. We have the recurring major rework costs, 15,000 every 13 years. So the cycle should be 1 cycle is 13 years, because that 15,000 repeat every 13 years. And we draw at least 2 cycles, so it means 26 years. So with that, we can draw the diagram for 26 years from 0 to 26, at least 2 cycles. So we have 13 here. So let's calculate. Initial cost 150,000. So you have that one at time 0, 150,000. And then you have 50,000 additional investment, 50,000 after 10 years. So it is 10 years additional investment, 50,000. The annual operating cost will be 5,000 for the first 4 years. So you have 1, 2, 3, 4, 5,000 for the first 4 years, 5K per year. And 8,000 thereafter. So you have 1, 2, 3, 4, 5. Start year 5. So we have 8,000 thereafter. So keep continue until infinity. 5. We have 6, etc. So that keep going. 8,000 to forever. But we only draw for the first 2 cycles. So keep continue. We have 7, 8, 9, 8,000, the same amount. So 8K per year thereafter. So it will be year 10. And you have over and over, etc. And then we have the recurring major rework costs, 15,000 every 13 years. So here, every 13 years, 15,000. And of course, at another 15,000. And continue, the next is at year 39. We have another 13 years. We have 15,000 spending for the rework cost. And the MAR is 15%. So the MAR is 15%. So that first we draw the cash flow diagram. And of course we can write down I equal to 15% per year. The step number two is find the present value of all non-recurring amount. So with that, we can have the present value P1 of the non-recurring costs. And in this case, the P1 that we call that here, non-recurring. The first is the initial cost, 150,000. The second is additional spending 50,000 at year 10. So you have negative 50,000. And you bring that to the present value. So you have it P over F, 15% and 10 years. So this is non-recurring. 15,000 every 13 years is recurring amount we have to deal with in the next step. So yes, 15,010, we can go to the reference for 15,000. And I don't think they have a table for 15,000. Then you can go to the equation P over F 1 plus I negative N, so that you can get the answer. So let that equal to, by now you can be able to find out that it's 2, 472 equations. So with that we have negative 162, 360. And step number 3, based on the slide here, find the equivalent uniform amount, A value, of all recurring amounts. Okay, so with that, we have that one. Step number 3, we have convert the recurring costs of 15,000. So because that every 30 years, we say equivalently how much for that every year. So 15,000 every 13 years into every year. So into annual value, and let's call that is equivalent value of you spending 15,000 every 13 years. Equivalent every year. How much? I call that the A1. Call that A1. So what is A1? So that is A1. And that A1 equal to, how can we do? So the first 15 years that you spend at the end of year 13, let's assume we can bring that, distribute that 15,000 here back to the previous 13 years. 15,000 at year 26, bring back to from year 14 to year 26. And similarly at year 39, you distribute that back to equivalent amount every year, right? So the first 15,000 at year 13, I assume, okay, how much at equivalent for the first 13 years, every year, same amount, we call it A1. Similarly, 26 years, at year 26, we spend 15,000, how much that equivalent for the from year 14 to 15. So do that the same. Then basically, as you can see, you spend 15,000 at year 13. I want to distribute that for the first 13 years, basically given F 5A. So with that, we can apply here. A1 is actually equal to negative 15,000. Want to find equivalent A over F 15% for 13 years. And by now, you know this factor equal to 0.0291. And with that, we have that equivalent amount equal to negative 437. What does that mean? With the MAR 15% per year, you spend 15,000 every 13 years. Equivalently, you spend $437 per year. So that is the equivalent amount every year from the recurring cost of 15,000 every 13 years with the interest 15%. So what does that mean? This is the first 13 years. The next 13 years from year 14 to year 26, we do the same, so that we can say that is the note here, note A1 apply to all other 13 years period. The next 13 years it applies. So it's the same amount over infinity, basically. So the step 4, if you go to the PowerPoint slide here, divide the annual amount to get the capitalized cost, right? So that one here, we have basically, we see the capitalized cost for annual amount, so that it got annual series. There are a few things that we need to do here. The first one, let me call, as you can see, the first, we have the annual amount is equivalent 437 per year. And the one is 5,000 for 4 years, and then 8,000 from year 5, year after, 5,000 first 4 years. How can we deal with that? So the step is very simple. We can use the first 4 years. If you spend 5,000 for the first 4 years, equivalently, we can say that it spent 8,000, and then you receive 3,000. Make sense? So I spent 5,000. Equivalently, I can say I spent 8,000 and I received 3,000. So the net spending is still 3,000. That is the bottom line that I show it to you here. So with that, I can assume I spent 8,000 for the first 8 years. Let's say that I spent 8,000 every year from year 1, and then I received 3,000 the first 4 years. Equivalently, I spent 5,000 first 4 years, and then 8,000 years after. Make sense? So with that, we can do it in here. We revise that cash flow later on. It messes up in there. So you can see there, if P2 is the 3,000. So let me make a note here. Spending, note. Spending 5,000 per year, equivalent spending 8,000 per year and receiving 3,000 per year. So the net, it will be 5,000. So with that, we can find out the first one is the 3,000 received, P2 equal to plus 3,000. I just assume I received 3,000. And that is for the first 4 years. So we have it P over A, 15% for 4 years. And that factor get in, we can get 15% for 4 years. You can get that factors 3.8117. So from that we can get this number equal to plus 11,435. 11,000. So that is the 3,000 for first 4 years. And then with that, I say the 8,000, it will last from time 0 to infinity. So that is become an A1, right? A1 for, and that one we can have A1 equal to 8,000. Instead of start at year 5, we say 8,000 per year, spending for from year 1 to infinity. So with that, we can find out the P3 with the capitalized cost for the annual amount, and that equal to A1, same amount, plus, let's call that A2. We already call A1, so A2 plus A1, which is the equivalent amount for spending 15,000 every 13 years. So we have that equal to A2, and the equation is A over I from your reference, capitalized cost, page 2, A over I, and that is divided by I. So you have that. So you have that one equal to A1 for 37, A2, 8,000 divided by I, 15%, 0.5. So you get that equal to negative 56,247. And then the next step here, step 5, add the value obtained step 2 to the value obtained in step 4. So with that, we can have step number 5, total capitalized cost. So we have P total equal to P1, which is step number 2, plus P2, the 3,000 for the first 4 years, plus P3. So we get that in negative P1, 162, 360, so, and negative 162, 360. P2 plus 11,435. P3 negative 56,247, and that equal to negative 207,172. And this is the equivalent amount. I spent now 207,172. Equivalently, we spend 150,000 first year, 50,000 at year 10, 15,000 every 13 years, and 5,000 at year 4 for the first 4 years, and 8,000 thereafter. So that is equivalent capitalized cost, and that is problem 3.